Good morning everyone. I welcome you on the second day of our FDP program. Along with Professor Bandopadhyay, we are honored to have our principal of Dr. B.Tech Engineering College, Professor Dr. Sanjay S. Pawar. We begin our program by requesting our principal sir to present with a memento to Professor Bandopadhyay. Please. Thank you. Now, I request our principal sir, Professor Dr. Sanjay S. Pawar, to deliver a speech on this occasion. Please.
Yeah, good morning all of you and welcome to Professor Bandopadhyay. And really pleasure to have you here. Though we are of a different domain, I am from telecom side, ICT side. Sir is from operational research, but the common in statistics where all of us are gathered here is a common one, and almost all the things, the methodologies that we have to learn in our own domain, they are the same. As you are from management side, I am from engineering side. Unless and until the statistic is there, almost all, I think I am many times again speaking also, no engineering, no management can survive without statistics. And then these have been, a lot of tools are coming up into picture, and a lot of softwares are there, and specifically from management orientation, visualization of a data. And in fact, maybe I think Sir also knows, in future there will be a case where you do not have a data also, which is to be practically implemented. To understand those models and to create those kind of a data, probably some kind of a tools will be used for that one. So visualization of a data and then utilizing this data is very important. And that's the reason I think Professor Bandopadhyay, expert in that field, will be delivering this lecture using certain tools. And I'm sure these tools will be applicable to you, your own areas, and will be effectively utilizing these things. And of course, needed for our own professional goals as well as research activities. This will help you. I welcome Sir once again, and please request to start. Thank you.
Thank you, sir, for your very inspiring speech. Yesterday, we have learned about data mining using OLAP and had a hands-on experience on the use of SPSS tool. Today, we should be learning about the data analysis tool Java-V, the concepts of reliability, validation, and matrix survival. In the second slot, we will be learning about the concepts of ECA, EFA, CFA, and structural equation modeling. In slot 3, we will be learning about the use of MOSV. In slot 4, Professor Bandopadhyay shall brief us on the concepts of non-parametric tests with cases. I think yesterday also we have covered some of it. And that will be followed by a question and answer session. We now hand over the section to Professor Gautam. Sir, please.
Good morning. First one tell me, yeah, my voice is audible? Suppose today actually this is my agenda. First we will give the concept of covariance and correlation matrix. board is visible. This is the number one. Number two is the concept of probability distribution. Concept of probability distribution. Number three is concept of sampling. Number four, concept of estimation. Number five, concept of testing of hypothesis. Number six, concept of ANOVA. Then concept of regression analysis. Number eight, concept of PCA. Number nine, concept of EFA. And if I get time, the concept of CFA. So this is my today's class agenda. Okay. And this is, I'm telling you, this is basically a sequential process. Basically sequential process. The question is why? Because when you start regression analysis, we need the concept of ANOVA. We need the concept of testing of hypothesis. We need the concept of estimation, because testing of hypothesis is based on estimation. And definitely estimation, without something we could not start estimation. And without probability distribution concept we could not start sampling completely. And definitely without correlation covariance matrix, how is it possible? And before that, yesterday we explained the concept of mean standardization. So another part we have to discuss about today the skewness and cutoff. This is very, very important. Skewness and cutoff. So can I wrap the board? So let us start with an example. Example is that. So this is a famous example in the Johnson Wilson. It's a very famous book of multivariate analysis, Johnson Wilson. So I have collected this example from Johnson Wilson in my own language, not direct Johnson Wilson. The example is that there are 7 subjects. 7 subjects. And the subjects are physics, chemistry, mathematics, Bengali, English, history, geography. Actually, I converted this because I am taking the class in West Bengal. Okay. So there are 7 subjects: physics, chemistry, mathematics, Bengali, English, history, geography. Now, there are total 100 students. Total 100 students given the examination in 7 hours. Okay? So, this is the data matrix. This is the data matrix. That is 1 to total 100. And this is the physics, chemistry, mathematics, Bengali, English, history. So, student number 1, get the marks. Similarly, so this is marks distribution. Marks distribution of 100 students in each subject. So we can say this is equal to 100 by 7 matrix. So how many rows? 100 rows. How many columns? 7 columns. So row denotes cases. Column denotes variable or attribute. Now that means there are total 100 cases. There are 7 variables. Now what we can do then? Suppose this matrix is given to us. So naturally when you start any research, we have the data matrix. Any kind of research, data matrix. The problem is, what is the problem of data matrix? In some data matrix, in total is scale variable. Some data matrix is the scale variable. Some data matrix is the only the ordinal scale. Some data matrix is a mixture of scale, ordinal plus log. This is the real problem. Okay. Now, today actually we start with starting the only scale. There is no data matrix, this is the only scale. Marks of the students. In the second half, when we start geography, we discuss about, the data matrix is the ordinal. Data matrix is the ordinal. Now, so this matrix is there. So what is the step 1 for doing research? What is the step 1? If you want to start, regression, if you want to start any analysis of probability, like factor analysis, like actual diffusion measurement, so then what is the step? Step 1 is find the mean and standard deviation. Mean and standard deviation of each group. Is it okay or not? Mean and standard deviation of each group. That is called the descriptive statistics. Now we add the 2 other measures, that is skewness and curvature. This is the number. Mean, standard deviation, skewness and kurtosis for each group. This is the number of. Number 2 is, step 2 is the graphically visualize plot. Graphically plot of it, which is called, suppose there are 100 observations, and for the physics you can use plot. For physics, chemistry, you use plot. Step 3 is we find standard error of mean, skewness and curvature using explode comment. Yesterday, only I discussed. Using explode command, easily we can find standard error of mean, skewness, and kurtosis. Question is why? The answer is for checking out. For checking out. Okay. So now, so after the completion of these steps, we have need some concept about combinations. Because in our 11th 12th, there is a chapter called permutation and combination. And it totally probability, sampling based on permutation and combination. And without combination, correlation matrix and covariance matrix is not possible. So I am giving a very simple example. I hope then you can easily recall the concept of combination as well as the combination. Not only that, easily you can recall the concept of sampling. Easily you can recall with a simple example. Always when since we are in a mature stage, we are the faculty. So if you find any example, then easily you can understand. So what is the example for because without combination concept, without knowledge of concept of combination, or combination and covariance is important. So what is that? Say there are the population size is equal to 4. I'm taking a very small example. So one of my, seriously speaking, when I was the real student of BSc, Students College in the States, so one of my teacher told me, if you want to learn A plus B whole to the power n, you have to learn A plus B whole square. And one by one you process. Don't learn A plus B and whole to the power n first. That means if you learn, that's why I have taken the example is very small. If it is capital N equal to 4, that is the population size, 4 and 2 size. Very small. Okay. Now, and then you understand what is the problem of statistics? What is the problem of big data? Big data. And why we welcome sampling? Okay, that's what we will make time and discuss. So n equal to 4 and small n equal to 2. That means there are 4 population sizes. And we can consider these population members are x1, x2, x3, x4. These are the population members. And n equal to 2 means any 2 members you can draw. Any 2 members we can draw. And for our understanding, we can take 1, 2, 3, 4. Then you can easily understand 1, 2, 3. So now, we are trying the 2 members. So now we represent this story in a real story. What is the real story? Now there are 4 students, ABCD. This is the real story. And 2 cinema. 2 cinema. So naturally, when n equal to, that means 4 students means capital N equal to 4. And 2 cinema tickets means small n equal to 2. Is it okay or not? That means any 2 student can go to watch the movie. So what are the 2 students? AB, AC, AD, BC, BD and C. Is it okay? So there are total 6 ways. There are total 6 ways. Now the problem is, when you enter into the cinema hall, so this is the screen of the cinema, movies. And this is your, the sitting arrangement. Sitting arrangement. Okay? And definitely AB can watch. AB can sit also, BA can sit. They can alter their seats. They can alter their seats. So definitely AB change to BA and AC change to CA. This is DA. This is CB. This is DB. And this is DC. I hope it is clear. And there are also 6 waves. There are also 6 waves. So definitely 6 plus 6, that is equal to 20. So now we can get the idea that what is combination and what is permutation. So combination, that is any kind of arrangement. If I shake my hand with Sion, at the same time Sion is shaking his hand with me. So that is the example of combination. We are using the formula of A plus B whole square, A plus B whole cube. So that is the example of combination. Okay. But when AB and BA are different, then it is the case of permutation. In maximum case, our sampling based on combination, some cases based on permutation. So definitely we had the 2 terms, that is the simple random sampling with retractor and simple random sampling without retractor. So then the concept of combinations and permutations are coming. That part. Now come to the part. So this is one combination and this is also one combination. Now we represent this idea, we represent this idea in the matrix format. Matrix format. Now what is the matrix format? So there are 1, 2, 3, 4. 1, 2, 3. Is it okay? 1, 2, 3, 4, 1, 2, 3, 4. So what is matrix? That is 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4. Is it okay? This is the matrix. So that is the 4 by 4 matrix. So 4 by 4 means total 16 entries. Total 4 by 4 into 4, that is 16 entries. Try to understand. This is called the diagonal element. This is called the diagonal element. And these are called of diagonal. These are called of diagonal. Is it okay? Diagonal of diagonal. So when 1, 2 is equal to 2, 1, that is, this is 1, 2 is same as 2, 1. Then it is called combination. When 1, 3 is same as 3, 1, 1, 4 is same as 4, 1, 2, 3 is same as 3, 2, that means below diagonals elements are same as the above diagonal element. Then it is called the symmetric matrix. Now what is symmetric matrix? The below diagonal is equal to the above diagonal. And that is the correlation, covariance. These are the example of symmetric matrix. When you consider the Euclidean distance matrix, that is also symmetric matrix. That is one more the major application, demerit. Nowadays it is the major demerit of correlation and covariance. Because in the real life scenario, it can never be a symmetric. Can I say I am giving a simple example? One day I am telling Shayan, I love you for 90%. Shayan says, sir, I love you also 90%. But it is true. Is it true? Maybe my sincerity to the Shayan may be 90%, but Shayan's sincerity may be more than 90%. Less than 90%. So that is, in the real life scenario, association can never be symmetric. So that's why association rules counts. Association rules counts. And these association rules, depending on probability. In probability, there is a concept of conditional probability. I hope you have heard the term. Today I have no time to discuss that. For conditional probability, the conditional probability is the relation between AB can never be equal to the relation between B. condition. I am going to a very interesting example. I'm going to Spencer for marketing potatoes. So after going potatoes, okay, I have to take the onion. So purchasing of onion depending on the purchase of onion. Potato. But same thing, the different story, purchase of potato may be not depending on the purchase of. So that is the condition. So in our base life, we are using the association. That's part. Okay. Now you can express this concept. That is, what is combination? Now N, C, N. I hope it's clear. So what is N? Capital N is the 4, C2. And what is permutation? When 1 to not equal to 2. These are different. So what is that? The NPN, that is equal to 4P2. I hope you know that. 4P2 equal to 3. So that is 6 plus. And what is total number of cases? Total number of cases, that is equal to capital N to the power small n. So what is capital N? Capital N is 4, small n 2, that is 16. Question is, why total number of cases 16? Try to understand. In case of total number of cases, we have to consider the diagonal also. There are how many diagonal elements? 4. How many off diagonal elements? Below diagonal 6, above diagonal 6. So that is 6 plus 4 plus 6, that is equal to 6. I hope it is clear. Now question is, how can I relate this concept with correlation matrix and probability? So suppose there are 4 variables x1, x2, x3, x4. 4 variables. When I have taken the example of 7 variables, 7 variables. If I take the example of 20 variables, 20 variables. So 4 variables, that is x1, x2, x3, x4. So we know, try to understand, x1 into x1, that is equal to x1 square. We know it. x1 into x1, that is equal to x1 square. So in the statistical language, we can say that is the variance of x. So diagonals are variance of x. That is the square of standard deviation. When you multiply the x1, x2, that is covariance, because there are 2 variables. Yesterday discussed. The concept of correlation and covariance occurs when there are more than 1 variable. So that is the covariance between 1, 2. This is 1, 3. This is 1, 4. This is 2, 1. Variance of x2. Is it okay? This is C2, 3. C3, 1. C3, 4. And variance of x. So this is the 4 by 4 matrix. Just to think, these the diagonals are called the variances. And off diagonal are called covariances. That's why it is called variance covariance matrix. That's why this matrix is called variance covariance matrix. Variance for the univariate, covariance for the value. Now, this is a very, very important part for structural diffusion modeling. When there are 4 by 4 matrices, how many variances? Oh, very good. Very good. Variances equal to. Very good. How many covariances? 6. Because symmetry. So covariances equal to 6. Is it okay? Sure? So what is 4 plus 6? 10. 4 plus 6 is 10. Now 4, since the variance for 6, try to understand what is the concept of mathematics. Since variance occurs with a single variable, that's why it is called force-C1. And covariance occurs with the 2 variables, that's why it is called force-C. Okay, and since it is 10, that means it is 5C. Compute 5 series, that will be 10. So this 5 we can write like this way, 4 plus 1 C2. Question is why? Because 4 are paired. 4 are the covariances and 1 are the variances. So that's why 4. Now we generalize. Because when you do our research, for some research 20, 30, so on. So that's why you consider there are p variables. I don't know how many variables. Suppose this is 5. So 5 we can break 4 plus 1. So 4 plus 1 C2. Now why I am breaking 4 plus 1? Because 4 is the 1 is the variances and 4 is the paired out of 4. That's why 4 plus 1. Now concept is, if there are total number of variables at P, there are how many variances? PC1. PC1. How many covariances? PC2. So in the 11th 12th class, there is a formula that PC1 plus PC2 that must be equal to P plus 1C. I am not going to the proof. Same. PC1 plus PC2 is equal to P plus 1. So that is the concept of covariance matrix. So I am telling why I have a computer. So question is, when there are 5 variables, so automatically question is that how many variances you have to compute? Clear? How many covariances you have to compute? 5, 6, that is 10. Now what is the total variance and covariance? 5 plus 10. And what is 15, 60? So this is very important. If there are 5 variables, covariance matrix is 60. If there are 6 variables, 7. If there are p variables, p plus. Because covariance matrix is a generalized. Because from the we start the concept of association from covariance matrix. Question is why? Because if the covariance between x and y is positive, then the association is positive. If it is negative, it is negative. It is 0. But correlation is the standardized. It's the transformation to make it easy. But the sign of correlation, depending on the covariance. Okay. First of all, you tell me is clear or not. Can I go to the next step? So now,
so can we generalize this?
This is generalization. P plus 1. P plus 1 is the generalization. When you write any research paper or with the factor analysis, with the structural diffusion modeling, always you have to write the generalization. maybe you have the 20 variables, maybe 10 variables. But when you write your methodology part, you have to write in the P plus. Otherwise, that paper will not be accepted. Methodology part, you have to write the generalized program. Suppose I am giving a simple example, then you can understand. If I start with a time series model, that is really interesting, ARIMA model. Say ARIMA 111. So this is the particular model. But when you write the methodology part, generalized model of PDQ, generalized model of now, for my case, T equal to 1, D equal to 1, and Q equal to 1. And that is the reduced model. Okay. So, now coming to the next part. What is correlation? Correlation. So again we start with 4 variables. Four variables. Starting 4 variables. So obviously, you know that what is covariance? I am giving a simple example. I want to calculate R11. What is R11? Correlation between X1 and X1. R11 means correlation between X1 and X1. Self correlation. So what is that? That is covariance between X1 X1 by standard deviation of X1 into standard deviation of X1. Because X1 X1. So covariance between X1 X1, that is nothing but variance of X1. A standard deviation of X1 into standard deviation of X1, that is also variance of X1. And that is equal to 1. I hope this. So always self-correlation is 1. Obviously, this is your best friend, myself. Initially, I will be correlated with myself. Every cell is a subset of itself. Is it okay or not? So that this is 1, 1, 1. So all diagonals. Is it okay or not? And correlation between X1, X2, that is R12, R13, R14, R21. R41. Is it okay? So how many, now next question is how many correlations you have to compute? It is also symmetry. 6. Below diagonal, how many? 6. So what is the formula for C2? That is 6. Yeah. So that's why when there are p variables, so that is equal to PC. That's all. So obviously this PC2 is less than P plus 1 C2. PC2 obviously, in case of covariance matrix, we have to compute P plus 1 C2. In case of correlation matrix, we have to compute because no need to compute variance in case of correlation matrix. This is the difference between correlation matrix and covariance matrix. So covariance matrix is the generalized and correlation matrix is the standardized. Again repeat, covariance matrix is the generalized and correlation matrix is the standardized. I hope it is clear. Okay.
The last
Last line হচ্ছে Suppose there are 4 variables, so we have to compute 4 C2. That is 6. How coming 4 C2? I am telling you can recall this. 1 factorial by 2 factorial into 4 minus 2 factorial. So that is equal to 24 by 2 into 2 and that is equal to 6. This is the computation. So we can easily, when you start NCR, that formula is n factorial, r factorial into n minus r. This is the generalized. Easily you can go. Now, 4C2 equal to 6. What is the meaning of 4? 4 means there are total 4 variables. Now we change 4. Instead of 4, we can consider 20. Then, I don't know. So we can consider p variable. I don't know the value of p. P can take anything. I hope it is clear to all of you. Now,
So if always correlation matrix is less than covariance.
so we always, the number of always, because no need to compute variance. But again I am telling you, covariance matrix, all yourself, structure which is model, which you start from tomorrow, then totally based on covariance. Total. All multivariate techniques, central, non-central, chi-square, central, so many things will come based on covariance. Full structural division modeling based on covariance. Because if you know covariance matrix, I am telling you, if you know covariance matrix, automatically you can derive the coefficient. Now coming to this another part, before there are 2 terms in statistics. One is the inter, another is the intra. These 2 terms is very important. One is the inter, and one is the intra. Is it okay? So what is the meaning of intra? The English meaning is intra means within. Within. And the English meaning of inter, between. Is it okay? Hello? Clear? So that means this part we discuss in case of correlation. So that means correlation divided into 2 parts. One is the intra, another is the intra. So we have to explain what is the meaning of intra, within, and what is the meaning of intra. So I am going to my example. There are 7 subjects, PCM, Bengal English and History. The previous example. And definitely, since there are 7 subjects, it creates a 7 by 7 correlation matrix. Initially, I have taken 100 by 7 matrix. 100 is the number of cases, 7 is the variable, and we can, since there are 7, 7 by 7. Okay. So in case of, try to understand, in case of 7 by 7, how many correlations to be computed? How many correlations to be computed? So obviously 7, 6. I hope BC2. And this 7C2 is nothing but 7 into 6 by 2 factorial, and that is equal to 21 correlations we have to compute. 21 correlations we have to compute. Is it okay? Now the problem starts. But the problem is a student good in mathematics, there is a high chance good in physics and chemistry. Good in mathematics, this is the general. Good in mathematics, there is a high chance good in physics and chemistry. So if you check the marks of the students, So that physics, marks in mathematics is good, scored good in physics. That is a common criteria. So then we can say the physics, chemistry, mathematics, their correlations are very high. Their correlations are very high. They are highly correlated with each other. Okay. The students, some students good in Bengali and English, some students good in English, good in literature, Bengali. It's a trend. And some students good in history, good in geography. I'm going on a trend, not the generalized. So, very interesting problem starts. That means a student good in physics, good in chemistry, good in, so we can, one objective for any data analysis is how to reduce the damage. How to reduce the damage. So initially we started the 7 variables. Now what is the complexity of 7 variables? So when it takes 7 variables, we have to compute 20 variables. Is it okay or not? So naturally, instead of 7, if you take 20 variables, so you have to compute 20 C2, that is 20 to 19 by 2, that is 190 correlation, not a matter of joule. Time of complexity is more. So we have to reduce time of complexity. And if the time of complexity is reduced, cost will be reduced. Machine cost will be reduced. Is it okay or not? So I am giving a very simple example. Then you can say, if we deal with the 20 variables, what problem will we face? It's a real problem. If we have 20 variables. And why we need this type of multivariate analysis? So the problem is, you have to estimate maximum to the power 20 parameters. And to the power 20, if we astonish, there is 10 lakhs 48,576 parameters to be estimated. And naturally, after some time, you will be mad. You tell me, please purchase one ticket for that. This is the real problem. So then, how we can reduce this? So there are so many techniques are coming. One of the best techniques, you know, the PCA. Now, when you deal the PCA, so PCA basically is the front end. We are doing the PCA, that is the front end. We are doing the EFA front end. We are doing the CFA, that is the front end. We have to know the back end part. Because front end part solving by any software. But if you know the back end part, you can write in your research paper. Back end part is very, very important than that. Don't mind. Okay. So, I am discussing about the back end part. And when I start, you know, the demo view or SPSS, that is basis. So we put the data, automatically result will come. Is it okay? Now, coming to the next part.
Sorry, Gautam.
No. So now coming to this part. So there are 3 groups. PCA, Bengali English, and history. That is the group 1, group 2, and group 3. Is it okay? Because why group we are forming group? They are homogeneous in nature. They are homogeneous in nature. That is the PCA are highly correlated with each other. That means a student good in mathematics, good in physics, chemistry. We are aware of it. A student good in Bengali, good in English. That's similarly for history. It's very good. So can you tell me how many members in the group 1? 3. 3 members in the group 1. So we can form this group 1. From this group 1, we can create matrix PCM, that is 1 RPC, RPF, RCP, 1 RCF, RMP, RMC. Is it okay? I hope it is okay. This is the correlation matrix for the three variables. Similarly, for Bengali English, we can create a correlation matrix. That is 1, that is RB, that is REB, and 1. And similarly for HG, same is HG, that is 1 RHG, RGH. Is it okay or not? Is it clear? So, this is the 3 by 3. This is 2 by 2. This is 2 by 2. That is the advantage of grouping. We are taking the help of advantage of grouping. Initially, there are all 7 variables and they are engaged. So now you tell me how many correlations you have to compute. Very good, 3C2. 3. Am I all right? 3. How many correlations you compute? Only 1. 2C2. How many correlations you compute? Only 1. Is it okay? So when there are 3 variables, we have to compute 3 correlations. When there are 2 variables, we have to compute a single correlation. So naturally, total correlations we compute 3 plus 1 plus 1 can be equal to 5. This is the advantage of grouping. When there is no group, we have to compute 21 correlations. And when you make group, only you have to compute 5 correlations. 16 correlations are reduced. Is it okay or not? Okay. Now the problem starts. One student told me, sir, I am good in mathematics. I also, my marks in English is very good. I am good in English also. So this is called within group. And this is called between group. Is it okay or not? Within group and between group. But some student told, sir, I am good in Bengali, physics, good in English also. So there is an interaction. There is a link between the members of the different groups. There is a link between the members of the different groups. And good in, and that is basically I am discussing about structural equation. This is the concept of structural equation. You have to prove it. So, I'm telling that part I will discuss. Say, this is very interesting. So that is group 1, physics, chemistry, mathematics. Group 2, Bengali English. And group 3 is clear. Problem is, here it is 3C2, here it is 2C2, here it is 2C2. These 3C2, these are called intra. These 2C2 called intra. And these 2C2 are called intra. Intra means within group correlation. Now, so there is a chance in the real life scenario that physics related with Bengali. Maybe chemistry related to English. Is it okay? So we know mathematics is the balancing. So we started with 21 correlation. 7 CP. And we get only 5 correlation. So automatically you have to ask the question, so what are the other 60? Is it am I wrong or right? Initially when you start the problem before your routine, 20, and apply some methods, we get 5. But what about the other 60? So definitely in mathematics, in statistics, in structural diffusion modeling, you have to give the balancing figure. You have to adjust. What is that? Can you tell me how many members in the group 1? 3. In the language of say 3D, is called cardinality. That you know. So cardinality of group 1, that is equal to 3. Cardinality of group 2, that is equal to 2. And cardinality of group 3, that is also. Is it okay? But there is the interaction between group 1 and group 2. So we want to compute interaction between group 1 and group 2. We compute interaction between group 1 and group 2. So what is that? That is Ng1 into Ng2. So that is equal to 3 into 2. Is it clear? Full interaction. Full interaction means a student good in physics, good in Bengali, physics, English, chemistry, Bengali, chemistry, English, mathematics, Bengali, mathematics. Maybe. So there is the cardinality of G1, G2 equal to 6. Similarly, cardinality of G1, G3, that is also 6. And cardinality of G2, G3. Tell me? 4. Very good. Now what is the total? 16. So now the question starts. Why we apply structural diffusion? Why we apply factor analysis? Because factor analysis, so first thing, PCA, there are 3 parts, that part I will explain one by one. Okay. Question is that, if you get all 21 relation in the right hand side, is there any need of methodology? Is there any need of methodology? All variables are related with all. So no need of any methodology. So what is our objective? How to reduce the interaction between them. So in mathematics there is a term, orthogonal transformation, object transformation. I am not using the mathematical jargon. I am not using the mathematical jargon. What is orthogonal and what is not. But this is the example of orthogonal as well as the object. Now, is it okay? How it is coming? Now question is, so when you go for any kind of model, so that is divided into 3 parts. Any kind of model is divided into 3 parts. So what are the model? First model is called independent model. Independent model. Second model is called hypothetical model. hypothetical model, and number 3 is called saturated. So there are 3 types of model: independent model, hypothetical model, and saturated. So if I ask you, we have 7 variables or 4 variables, or 4 variables are independent, then they are called independent models. They having no association with each other. I am telling you, we entered into MBA class, first class. So there it is a mixture, heterogeneous. When some students from B.Tech, some students from BSc come with chemistry, some from economics, it is a simple entry. So first we count the number of students. The number of students, 6 students. So then I tell you divide 60 students in your specialization. So then B.Tech, this is that. So how many B.Tech students? So 50. So 15 from it. How many from economics? Say 10. How many from one? I say chemistry. So naturally 60 students we can divide into some groups. So that is called homogeneous. But the problem starts if there is no group. All are different. They are all independent. So that's why it starts with the independent. So what is the example of independent model? Simple example is regression. Regression. So very interesting. Independent model, we are giving the example of regression. Again we face some problem. Regression, that is one dependent variable and more than one independent variable. Because today I am discussing about multivariate. Okay? Multivariate. So when there is one dependent variable, more than one independent variable, there is a one condition, assumption that these all independent variables having no high correlation with each other. No high correlation with each other. This is the first assumption. Second assumption, they follows the linearity. Second assumption. Third follows the normality. Fourth assumption is error definitely will follow normality. This is the assumption. But most of the real cases, I am telling you, your assumption, maximum assumption is correct. Maximum assumption is correct. Then you take the help of central limit. That is another issue. So, I am telling about, so that means regression divided into two parts. One is called explanatory model, and one is the predictive model. There are two. So today I will show you the concept of explanatory model as well as the predictive model. Now come to the part is hypothetical. So question is why these occurs? In the real life, we are always approaching from independent to hypothetical model, hypothetical to saturated. This is the approach. So there is basically it's a very interesting term which is called continuum. The term is called continuum. So that is the extreme left and extreme right. Extreme left is not possible. Extreme right is not possible. If we go for extreme right, we want to stop, saturate. Okay. So this is our approach. Independent to hypothetical. So for independent to hypothetical, we apply PCA. We apply here. For independent. And for hypothetical to saturated, we apply CFA. So definitely, we have to know first, independent, what is actual independent model. That we have to know regression first. Are we feeling both? Sorry, yeah. You have to follow the regression. So then I will show you some cases that regression failed. Regression failed means this independent part failed, totally failed. Then we take the help of hypothetical model. And for the hypothetical model, we solve the PCA and EFA. And then I will show that this EFA part also failed. Then we have to take the help of structural equation. So this is
Sir, if EFA is fine, then there also be no slave rate, then why do we do that?
EFA is fine.
But if EFA comes fine.
Okay, then
also
but
the answers
how
from
we
the
know your EFA is fine?
The answers from
My question is how do you know your EFA is fine? Basically, EFA based on orthogonal transformation. And the problem of orthogonal transformation is that you are omitting the condition of oblique transformation. In EFA, there is no concept of oblique transformation. But when you EFA you plus oblique transformation, then you can say that EFA is correct. Very good question. Very good question. But when you solve EFA, you will find your question is fine. But question is, after EFA, then gives the basically, orthogonal transformation moving. So in 2010, there is a very interesting paper. How we check that is not possible in Jamovi, that not possible in SPSS, that is solving the R2 part. Actually, in 2021 we have solved that problem. So that problem solved. Why the CFA? The tool is there. That part, if I get time, I'll show you. If I get time, how we can make the tools. Very interesting. 2010 it is published. Can I? Now I am coming to so I am taking a very simple example. I hope you will understand. Say, I am taking a real life example. First example is example case 1. Case 1. Selling price depending on size and age. Very simple example. Why we know it? How many independent variables? Can I ask you one question if you don't mind? Can you tell me how many models you can make? Just simple, don't know. Say one dependent variable and two independent variables. That's all. How many models you can generate? Yeah. Thank you. So first model is selling price is equal to no dependence on size and age, that is constant. There is no effect of, try to understand, no effect of size and age on selling price. This is the one model. What is the second model? Say this is equal to say beta naught. Selling price, high only effect. Only size. See, am I wrong or right? Next, selling price, only age. And selling price, is it okay? Okay. So combining these three, we can write beta naught, beta 1 size, beta 2 age, and which are the size index. There is interaction. Then how many, try to understand, how many parameters to be estimated? Newton, how many parameters? Oh, maximum parameter. Very good. So parameters, when p equal to 2, the number of parameters that is equal to 2 to the power p, that is 2 square, that is equal to 4. That is called maximum number of parameters.
So why do we take constant?
Because we are getting, say, y equal to mx, that is without constant. But in the real life scenario, always x and y are not same. Suppose x taking the value 1, then y 1, x 2, y 2, it will not never. Suppose x taking the value 1, y taking the value 2.
Technically, sir.
Technically.
But when we do it in the research, we don't take any constant.
No, suppose I am telling you, suppose when you start the problem, so your initial condition is there is no independent. So definitely only you know your output, that is the dependent. So for the independent constraint, basically we are when you using a model, we are getting the average model, expected value. Then what is the mean of this model? So what is the mean of y bar? This is the constant. This is the constant. So definitely y equal to, that's why when you put some theoretically, when you find the regression model, that is called, this is the model. This is the model. Because this is the constant.
Sir, if we apply it in behavioral science,
Yeah.
for sales or for finance, there can be a constant.
Okay.
But when it comes to behavioral science,
Okay.
what can be the constant?
No, no, in the behavioral science, basically we are not using this type of conventional regression. No, we are doing this, but I will not tell anything. But basically in the behavioral science, there are so many hidden parameters. That we are going for the mediation.
No, mediation operation we
Okay.
don't, but if it's a simple
No, I'm
independent
telling you, behavioral science is that is based on some ordinal values. Some ordinal values means there are some variable which is the ordinal. And now it is the regression. This is the first problem. When you see any regression model on the basis of ordinal values, that is simple regression can be made. This is the first problem. So then we go for hierarchical regression. Hierarchical regression. And in case of hierarchical regression model, we see that constant will come. Question is why I'm telling you. If we don't know y equal to simple px, constant, I'm giving a simple example. Then I want to change the one unit of x. Then it is y dash. Now what is the change of it? Y dash equals b, no constant. No constant. So we are interested about the change of this. Change of this. But if you ignore this constant, that's a real problem. Because if you take y equal to bx only, so that means for x equal to 1, y always b times this. B times this. Only we are taking the variable part. But in any kind of model, you have to consider some fixed part. That's why interesting. And I'm telling you, this concept, I'm telling you, that concept you are telling me. But when you make it standardized, it's no concept. But if you break the standardized form, and if you check the any kind of output, if you follow the standard data, then you can get that. So, very good question, Jessica. When you go for research analysis, you need the analysis on the basis of standard.
yes, we take the standard.
Standard. Then you are,
That is why this constant gets.
then you get it. I hope you, thank you.
You also have to include the error terms also in the model.
The error term I will include in the not parameter estimates. Then that is obviously. Okay. Obviously. I am asking about question what is the problem. So just to check, here the interaction between cycles. Here. So if we can you tell me if we can take it, this is the multi-current occurs. And we have to reduce this in case of explanatory model. But in the real life scenario, we have to consider. This is a predictive. Now come to the part, the problem occurs, I am telling you, when there are three variables, when problem starts. Let me tell you what problem we will face. Just idea, three variables.
So it will be two interaction.
Yeah, very good.
Two interaction and between these two.
Very good. That means three variables means we have to estimate two cube, that is 8 parameters. So what are the 8 parameters? Now y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Am I wrong or right? Plus beta 4 x1 x2 plus beta 5 x1 x3 plus beta 6 x2 x3 and then beta 7 x1 x2 x3. Now my question. Now my question. Can you consider this? Yes or no? The answer is no. Actually, the question is why? Because x1, x2, x3 is the intersection of x1, x2, x1, x3 and so naturally when you consider the two variables x1, x2, x1, x3, x2, you need to consider x1. So that's why you can easily remove this.
Sir, I have a question.
And you definitely.
By extension of this argument,
Huh?
by extension of the same argument,
Huh?
can we not say that we don't even need to take any cross product term because the terms are already there? So the cross product correlation will anyway be calculated.
No, no, no. I am discussing about suppose this is my perfect independent model. This is the problem. Perfect independent model. That means there is no interaction between x1 and x2. But in some model, there are some interaction between x1 and x2. So then you have to consider this. No interaction between x1 and x3. You can remove this. Easily you can check it. Similarly, no interaction between this, but no need to consider this one. So this is where question is why I am telling you when the number of variables are more, they will face the problem. Okay, and this concept is called in the term multicollinearity, and that easily you can solve by the that what you know I will explain. Okay. So I am giving, since there are so many mathematics teachers, I know, so I am giving a very interesting formula for, say there are three variables. So there is PC0. What is the meaning of PC0? Constant. PC1, there is only a single variable. Clear? PC1. PC2, only there are two variables. And dot dot dot, PCP, that means interaction of p variables. But in ours, so if you know the binomial theorem, if you add this, that is equal to 1 plus 1 whole to the power p and then 2 to the power p will come. That you know. 2 to the power p will come. Now question is, in our social science, we consider only this one. Question is why we consider only up to maximum 2. So social science research, not only social science, any machine learning also, PC0 plus PC1 plus PC. That's all. So if you give P equal to 4, so there is a 4C0, 4C1 and 4C2. So that is equal to 1 plus 4 plus 6, maximum 11 parameters to be. This is very important. Okay. I am telling you, okay. First of all, you tell me up to this okay or no? Now, so Sujosika man asked me a very interesting question. So I am answering this part. Yesterday, one ma'am asked me, sir, can you explain the OLS part? I don't know. You can. Raise your hand, OLS part. So when I discuss OLS part, then you get the answer. Question is why? Because this is the equation. Already sources are told me. This is the equation. So what is the equation? Now this is my output, this is my model, and this is it. Is it okay? So this is called observed. This is error. Error of observed. So now we can replace this observed is capital Y. Better you write small y. Model is capital Y. Is it okay? Because this is your data matrix. This is your data matrix. Y is there. X1, X2, dot, dot, dot. This is it. And from this data matrix, this is your observed. So now how many observed? There is one dependent variable. And this is your model, that is capital Y, obviously function of x1, x2, Is it okay? What is depending on the independent variables? Now come to the point. What is our objective? Objective is to minimize this. What is error? Capital Y minus 1. 5 minutes is error. 5. Error equal to small y minus capital Y. Is it okay? So these y, this variable. How we get this idea of this one? Maybe linear, maybe non-linear, maybe straight line, maybe quadratic, maybe third degree, maybe exponential, maybe trigonometric, anything. Anything. So when we start our ordinary least square, we take capital Y equal to A plus Bx. Generalized linear. So that is, and this error may be negative or positive, that's why you make it square. So I am telling you, there is an assumption that error will follow normal distribution. So you can ask me the question, why? Because error is equal to small y minus capital Y. So when you solve the problem, try to understand, solve the problem, you get capital using this parameter. And after getting capital Y, you easily calculate the magnitude of it because you know small y. So when you calculate the magnitude of error, some errors are positive and some errors are negative. Am I wrong or not? And these some errors are positive and negative, they are symmetrically distributed. Symmetrically distributed because in between 0. So below, above 0, there are some negative errors. Below 0, there are some negative errors. And definitely these errors are symmetrically distributed. That's why these errors follow the normal. Okay. Now question is, why and since errors are normally distributed, and this positive and negative will be cancelled. Cancelled, and that's why mean of error is 0. Mean of error is 0. So that's why this is the assumption. Error with mean 0 and normal variance is the same. Is that okay? Now coming to the part, OLS part. So, error square, that is equal to small y minus a minus bx. Basically, is it okay? So what is sum of square? There is error sum of square. And now how many parameters involved? A, B. So then simply you apply calculus. You apply the partial derivative concept. It is, you can take s square, del s square by del A and del s square by del B. Equating with 0, we get it. Now question is, that is the real problem. We are not writing in the research paper. When you solve this is not the sufficient condition. This is called the necessary condition. Necessary condition, you know, for mathematics, and if you go for the second order derivative, this is then it will satisfy the sufficient. I am not going for that. That is the mathematical jargon. So, now coming to the part, when you solve this, we get the two equations, very interesting. One equation is A, that is equal to y bar minus B. We get this equation. What is A is the constant part. Constant part. And if your y bar is equal to bx bar, so automatically A equal to 0. So you have to check it. So what is your y bar? What is your x bar? Already I told you step 1 you have to compute x bar, y bar. And if your y bar greater than bx bar, so automatically A is greater than 0. Positive intercept. And if it is y bar less than bx bar, automatically the negative intercept. So then, for your research domain, you give the concept of slope from your research domain. And if you give the concept of research domain, automatically you can derive this part. Automatically, because you know the value of B, you know the value of y bar, you know the value of x bar. Is it okay or not? And similarly, so from this you can get the idea of it. But question is, when you deal with any software, so that gives some concept of standard error. So what is standard error? Standard error, that you can discuss after T, because T is waiting. Is it okay? Why does it not? Yes, because if I can go for derivation, we will go. But my interesting part is the derivation, I am telling you. But you know, this is not the class. Just you think how we calculate A and B by the least square method. Why we are using least square method? Because our objective is to minimize error. And for the minimization of error, I am telling you, we are finding R square. A very interesting part. So there is some goodness of fit statistics. So goodness of fit statistics, another is the badness of fit statistics. So what is the difference between, then you can understand self. What is the difference between goodness of fit statistics and badness of fit statistics? So what is the goodness of fit statistics? That to increase some measures. Goodness of like R square, goodness fit statistics. Like adjusted R square, goodness fit statistics. Okay? And what is the badness of statistic? AIC criteria, badness fit statistics. SIC criteria, BIC criteria. These are called the badness. So if these are minimum, good. If these are maximum, good. So it's a trade-off. It's a trade-off is going in the research. So how to maximize the goodness fit and how to minimize the. And that's why when we get the different model, so we select that is in solving the cell, we select that model where these all goodness fit conditions are satisfied and badness fit.
And there is another criterion, for example, sir, the BW. If I remember correctly, it should be around 2.
The BW, definitely that is proving for regression.
So in that case, that is neither goodness or badness.
Yeah.
Like it has to be one particular value.
Darwin-Watson, when I consider the cross-sectional data, obviously you have to check the Darwin-Watson. Because Darwin-Watson gives the concept of autocorrelation. And autocorrelation relates with the error analysis. Is it okay or not? So we are thinking error analysis, why? because area follows the mean zero. Mean zero, and when it is mean zero, then automatically the Arvin-Watson value will come to. That is a very interesting, because autocorrelation is zero. Autocorrelation is zero. And obviously we have to check this Arvin-Watson. Thank you. And that's why in the last part of regression is autocorrelation. And the rest will be a test. Is it okay? So standard error, I will explain why it is important, because when you go for outlier checking, standard error will take everything. And from after till D, I will give the concept of testing of hypothesis. Because otherwise, simple is a mechanical job. Just answer them.
We will be back by 12:15.
12:13.
12:15, 1-5.
তখন যদি তোমার কোনো মিসিং ডেটা থাকে এমন সেই জন্য আমরা অ্যামোসে কি করি, আমি তোমাদের পাঠিয়ে দিয়েছি। অ্যামোসে কি করি, আমরা নিজেরা একটা কোরিলেশন ম্যাট্রিক্স তৈরি করি, করে নিয়ে ওইটাকে পাস করি। অ্যামোসটা কিন্তু ডেঞ্জার, কিছুতেই ও মিসিং ভ্যালু আলাদা। এবার তুমি তাহলে ওই 13 বাই 15 করে তো তুমি পারবে না, তখন ওইটাকে আইদার মিসিং অ্যানালিসিস করতে হবে, করে ওটাকে সমান করতে হবে, করে করলে কিছু আছে। একটা জিনিস আমি বলে দিলাম, যে কাজগুলো করেছে একটু অ্যালগোরিদমের দিকে যাও। আমি তো দেখতে পারবো না, তোমার এরও ডবল সিবি, মানে লিভ ওয়ান আউট ক্রস ভ্যালিডেশন। আমি এগুলো কিসে পড়িয়েছি, এমসিকেবিতে একটা অটোমের কোর্সে দেখেছিল, ওখানে পড়িয়েছি। ওরা ভ্যালিডেশন অফলাইনে কোনো জায়গায় পড়ায়, অফলাইনে তো কোভিডের জন্য। আমি তো শিখলাম এই কোভিডটা আমাকে একটা আশীর্বাদ হিসাবে, মানে পড়াশোনার সারাদিন পড়ি, কী করবো পড়ি, আর্টটা শিখলাম, পাইথন শিখলাম। তোমাকে কিছু না ধৈর্য, বই লাগবে, নোটস। আমি আর একটা কথা ভুলভাল শিখি, মানে কি অনেকে একটা কনসেপ্ট দেয়, কনসেপ্টের মধ্যে এটা কিন্তু করতে হবে। শুধু এইটা মাথায় যে আমার আরএমএসিটা কম হচ্ছে, আমার যত আরএমএসি কম হবে সেই কথাটা। আর একটা কথা বলছিলাম, বায়াস মনে রাখো, বায়াস আছে, এই দুটো কথা কাম যেন আমার মডেলে যেন বায়াস আছে, আর এরারটা যেন তাহলে বায়াসটাকে চেক করবো, আর বায়াসটা দিয়ে এরারটাকে বুঝবে। আর একটা জিনিস বলছি, ট্রেনিংয়ের টেস্ট এখানে বলা যাবে না, এটা ট্রেনিংয়ের টেস্ট এই কাজ করছেই কেন বরং তোমার চাকরি সঙ্গে সঙ্গে চাকরি সার্কেলকে 70% করে কিছু আসে, আর 120টা আসছিল, এই 280টাকে দিয়ে তোমার কাজ করছে, রিসার্চের কাজ করা, স্কিল লেভেলে পাবে। এবার বাকি যে 120টা হলো, দেখো ওই 120টা দিয়েও সেম কাজ, দেখো না মজাটা ব্যাপার। এবার তাহলে এটা হচ্ছে বিভিন্ন স্যাম্পেল হচ্ছে, এই যে 280টা দিয়ে কাজ করা রেজাল্ট, যাই হোক এটাও দেখলে এই রেজাল্ট মোরালের সেম। এবার যদি দেখো যে এই 120টা রেজাল্ট খুব এফেক্ট হয়ে গেছে, তারপর তোমার ঘটনা এটা খুব
স্যার, যিনি ধরুন মেল ফিমেল একসাথে নিয়ে এসছে, একবার একটা হলো যে
সেই আমি এজ গ্রুপটা বা মেল ফিমেলকে আলাদা করে সেম কাজ করলাম একদম আলাদা যে এজ গ্রুপ আলাদা
আলাদা যেটা আমরা ফ্যাক্টরি করি মানে গ্রুপ ওয়াইজ ফ্যাক্টরি হবেই
একদম আলাদা
হবেই এইটা কিন্তু খুবই
এটা তো খুব দারুণ মানে
দারুণ এক্সপ্লেন করার জন্য খুব এটা হচ্ছে বিহেভিয়ারাল আমি কিন্তু বলছি এই কাজগুলো একটা ক্লাসে তারা এত কিছু বলা যায় না বলে দিলাম হ্যাঁ
আপনার সিগনেচারটা আমি সামনের কাছ থেকে
হ্যাঁ
স্যার আপনার নাম্বারটা আমি একটু নেব
আমার নাম্বার সোজা 9434 788 788 ঠিক আছে না
স্যার আমি লাঞ্চের সময় একটু কথা
না খুব ভালো কোশ্চেন ছিল এরারটা আমি ইচ্ছে করে ওখানে খেতে গেছি গাড়ি দেওয়ার পরে খুব ভালো
ঠিক আছে
গল্প করে বলতে পারি আমি শুধু গল্পটা করবো পুরো ডিটেলস টেস্টিং করতে গেলে মানে আজকে সারাদিন লেগেছে Can I start now? আপনি শুনতে পাচ্ছেন আমার কথা বলা আওয়াজ যাচ্ছে বলার মাইক লাগাবো হ্যাঁ Hello. Audible? Hello.
তোমরা মার্কার ঠিক আছে নাকি আর লাগবে
আরেকটা ব্ল্যাক হলে ভালো হতো আচ্ছা আচ্ছা আচ্ছা
আছে
So I'm writing one statement that Philips is a company. So I'll give the concept of testing in a story manner. I hope then you can easily understand. So Philips is a company. So they are the manufacturer of electric bulbs. Okay. So before launching the product in the market, so Philips company will give some documents. So definitely we can consider Philips company as the population because they are the producer, they are the manufacturer. And we are the customers, we are using the tubes. Okay. So when Philips company launching the product in the market, so they give some documentation. So what is the documentation? In the statement format. In the statement format. So what is the statement? The average burning hours of tube greater than equal. This is the Philips company's statement, proposition. And we are the customers. We are using samples maybe 20 tubes, maybe 30. So what is our proposition? Our proposition is average burning hours is the less than 1. This is very interesting. So we are the researchers. The researchers are giving the basically customers, alternative. So initially when hypothesis starts, then basically based on statement. But only for solving that hypothesis, we take the help of numeric parts. Because statement is basically a character. Okay. So, hypothesis starts from composite form. Composite form. So what is composite form? This is the composite form. That is average burning hours of bulb greater than equal to. Question is why it is composite? Because greater than equal to 1000, there is no upper limit. Greater than equal to 1000 means 1000 anything beyond. Similarly, less than 1000, no. So this is the real form. So then composite hypothesis, then for the composite hypothesis write in the abbreviation. So what is the abbreviation? Symbolic abbreviation. So they use symbolic abbreviation. So what are the symbolic abbreviations? So if we go for average, the symbolic abbreviation is B. Okay. If it is standard deviation, symbolic abbreviation is sigma. If it is correlation bivariate, symbolic abbreviation is rho. If it is regression coefficient, symbolic abbreviation is beta. And if it is proportion, symbolic abbreviation is P. And now when you solve in structural diffusion modeling, this is the symbolic abbreviation sigma. So these are called the symbolic abbreviation, which denotes the population characteristics, which is called the population parameter. So these are called population parameter. Population parameter. So naturally population problem is this population parameter like mu, sigma, rho, beta and capital P and so on. These are not known. This is the real problem. So we have to estimate this population parameter with the help of sample statistics. So we have to estimate this mu by x bar. We have to estimate this sigma by s, rho by r, beta by b, p by small p, sigma by capital S. So these are called population parameters and these are called sample statistics. So now this is your statement given by the manufacturer Philips company. So we have to convert this statement, in terms of the symbol. So we can write mu because average greater than equal to 1000. Because Philips company, there is a population. And researchers are, testing the manufacturer. So definitely mu less than 1000. Now the problem starts. How you solve the problem? Because greater than equal to 1000, no upper limit. Less than 1000, I don't know what is the lower limit. So then we think of it, so better from composite hypothesis, from the manufacturer point of view, can you write any hypothesis in the exact form. So initially we know the composite hypothesis. And from composite hypothesis we know the alternative. So automatically now we can go for solution. How we can solution go? We can write now mu equal to 1000 and mu less than. That is called null hypothesis. That is called alternative hypothesis. So null hypothesis is created from the composite hypothesis. So question is, so we test this null hypothesis, and this is the alternative hypothesis on the basis of sample, because we know the sample we are collecting, customers are using. So when you write your hypothesis in your research paper, you write only your alternative hypothesis, because that is the researcher. No need to write null hypothesis. Always you write alternative. Okay. So, and these alternative hypotheses basically based on sample. Is it okay or not? And when you go for sample, when you consider the sample, that is very interesting. When you consider the sample, so definitely there are some errors. There is error. And these errors divided into two. One is called standard deviation, which is based on population. And another is called standard error, which is based on sample. And that's why in testing of hypothesis, we use standard error. Because testing of hypothesis based on sample. Is it okay? Now the question is, this is X bar. X bar.
Sir, I have a question last. Sir,
based on population का भी की बोले
in its store,
population का भी standard
Average banding of 1,000.
sample total is standard deviation
Here, you have taken H1 equal to mu equal to 1000 and H2 is mu less than 1000. So we take other term, we take Phillips one as an alternate hypothesis.
The manufacturer, producer, always the now. Always now. Consumers always the alternative. Researcher, hypothesis always alternative. Always. I am coming to your point. I am coming to point. Suppose I am coming to your point. That's a very good question. Suppose I am solving correlation. Very interesting. Correlation. So what is my hypothesis? This is a real question. I am solving regression. What is my hypothesis? So definitely we said, first we said alternative. So what is my alternative hypothesis for my correlation? My alternative hypothesis correlation is rho not equal to 0. I am thinking my correlation can never be 0. That is called alternative. So automatically our now rho equal to 0. In case of regression, what is the alternative hypothesis? The beta not equal to 0. Coefficient not equal to 0. Because if our coefficient is 0, no regression. The coefficient of x is 0, no regression. So this is my alternative hypothesis. And what is the null hypothesis of beta equal to 0? Is it okay or no? Suppose, in case of, say, we are testing mean. I am testing mean, say, Gautam. And definitely my alternative. So I am telling you, recently, maybe time is a constant. Recently, there is a very interesting thing going in for the, the online selling, like Amazon, Flipkart. There is a concept is called P-hacking. There is a concept is P-hacking. And P-hacking basically based on this testing of hypothesis. Because if you can hackers, if you can hack P-hack, the value, so easily, we can satisfy the customers. And the competition is going on in Amazon, Flipkart, there are so many big companies. P-hacking. There's a huge, just go to the Google and type with P-hacking. There are so many literature. Very interesting topic. And this total P-hacking, based on this testing of hypothesis. I'm coming to your point. So, I'm telling you, this is the most important question. When you go for chi-square testing, your H0 and H1 is fixed. Do not change. When you go for correlation testing, your H0, H1 will be fixed. With your regression, H1 everywhere. When you go for structural diffusion modeling, your hypothesis is fixed. When you go for factor analysis, and it's called factor analysis, definitely there are some hypotheses. Hypothesis is fixed. And you have to interpret your hypothesis in the sentence. In the sentence, from your domain. Now coming to the part, say there is a concept called critical friction. And that is the term is called type 1 error and type 2 error. These are very interesting. So I am telling a story. I am telling a story of COVID situation. I hope that you can understand COVID situation. So that is there is no COVID and COVID. Actually no symptom. Very interesting. And go for medical test. RT-PCR test. So then again no COVID and COVID. Okay. And you have, suppose there are total 100 patients. 100 patients. And out of 100 patients, initially 60 no COVID and 40 COVID. Original, observed, no symptom. Now go for RT-PCR test. So then out of 60, 50, and this is 10. And this out of 40, this is 30, and this is 10. Problem starts. Problem starts. Why problem start? Initially no COVID, and after testing no COVID, this is the correct decision. Initially COVID, after testing COVID, correct decision. Correct decision. Is it okay or not? And here the no COVID, suppose if you have this is a minus, this is plus, this is minus plus. No means minus. So this minus changes to plus. No COVID changes to COVID, dangerous. And their COVID changes to no COVID. So both are wrong. Both are wrong. That means both are error. So there are two types of error. Is it okay? So out of these two errors, one error is mostly dangerous and one error is not so dangerous. Now which error is the mostly dangerous? Negative 2? So which is the mostly dangerous? That is called the type 1 error. So in the language it is called probability of rejecting the good lot. Probability of rejecting the good lot, that is called type 1. And probability of accepting the bad lot, that is called. So definitely no copy is a good. We are rejecting. So probability of rejecting the good lot, that is called type 1 error. And in the machine language it is called the false code. So now the main objective is, and that's why we are this matrix. This matrix is called confusion matrix. So we are confused. By any means, our objective is how to minimize this error. So that part under another chapter. How we can minimize this. Okay. So this probability of rejecting type good law, that is very dangerous. So obviously we have to reduce it. We have to reduce it. So I am showing a very graphical representation. Then you can understand what is the problem. Graphical representation like this. Say this is your y-axis, this is your x-axis, and this is your percentage of defective. Percentage of defective of a lot. And this is your probability of acceptance. And naturally you know probability lies between 0. So it is, if the percentage of defective is 0%, so obviously probability of acceptance is 1. So already, before starting the hypothesis, there is an understanding between the producer and consumer that maximum level we can reach the 5%. This is the understanding. This is the understanding. And when this is understanding, but in the real life scenario, what happened? Suppose your percentage of defective is 1%. Obviously you have to accept the 1. Because only the percentage of defective is the 1%. But there is a still chance of rejecting. Say 0.95. So that is the probability of acceptance is 95%. There is a chance of 5% chance of rejecting. Not 100% we can accept it. So automatically 2%, similarly the percentage of acceptance will be less. So I am telling a very interesting story, then easily you can understand that what is the meaning of type 1 error and type 2 error in the real life scenario. Level of significance definitely confidence obviously, and we consider the 95% confidence level. That is the real thing, that is the complement, reverse part. Okay. Now, I am telling you what the problem we face in the real life scenario. Say, for understanding, I am telling a story. So this is a box, very interesting story. Easily you can understand. And this box containing, this is the called 100 kg box of potatoes. Very interesting story. 100 kg potatoes. Okay, so definitely there are some seller and buyer. Seller are the null hypothesis. And I am buying alternative. So definitely before purchasing any product in the large amount, so any buyer asks to the seller, what is your cost of your product? So naturally I can say, seller can say 20 kg, 20 rupees per kg. Then another question, if we take 100 kg, is there any discount? The next question. Okay, if you take 100 kg, I'll take 18 per kg. The second question. So what is the third question? Third question is, out of 100 kg, can you tell me what is the percentage of defective? Obvious question. It is not possible 100 kg is all are defective less. So then the seller told maximum 5%. Is it okay or no? So composite hypothesis comes that less than 5% composite hypothesis and alternative greater than 5%. Easily you can convert it to testing problem. Okay. Now, since we are the human being, and for any business, it is not task. Because I was in a business for 30 years in my life. So I know what is business. Whereas in Mawar, I feel proud for them. Now that's why I am giving this example. So now, what anyone will not task. What I am doing, we pick some sample. It is a common habit. Pick some sample. And when you pick some sample, and we pick 10 samples, by chance, that's why it is called probability. By chance, out of 10, 5 samples are defective. Is it okay? Maybe. So we reject them. But initially I told you this error is the really honest error. So probability of rejecting the lot, good lot, initially it is good lot. So that is called the type. Is it okay? So naturally, when this happened, in the next day, seller changed his mind. Seller changed his mind. So I will be the legal host. So in the next day, and definitely this type of decision changes from product to product. Supple the full bags. Suppling the bags. And after suppling, there is a 50% of the good product. Full. Because seller knows the psychology of the customers. This is the main thing. Psychology of the customers. And the full last 50% full of the bad. Same thing. Another buyer. Ask, what is the per kg? I told you. Discount? Yes. What is the per kg? The 16 rupees. 4 rupees discount. What is the percentage of defective? Only 1%. Naturally, pick some sample, all are good. Customer is satisfied. Went into his own residence. So that is the concept of type 2 error, probability of accepting the report. So these situations is occurring in case of any classification. In case of SPL, in case of logistic, in case of discriminant analysis. Okay, and what is our objective for all types of classification problems? How to minimize this type 1 error and type 2 error, and that's why we apply sensitivity. So our level of significance, that is alpha, that denotes type 1 error. Denotes type 1 error. Now I am coming to the next part. When you start regression, we need, 3 types of testing. 3 types of testing. One is the correlation testing, one is the regression testing, one is the classification. 3 types. So for the correlation testing, that is the hypothesis is rho equal to 0, H1 rho not equal. This is called correlation. So what is rho? Rho is the population parameter. And for testing our hypothesis, we need some test statistics. Test statistics. So what is test statistics? Test statistics, there are two types of test statistics. Two types of test statistics. One is the theoretical test statistics. Another is the sampling test statistics. There are two types of test statistics. Theoretical test statistics. Another is the sampling test statistics. Now what is the difference between these? You know, in our research, social science research, there is a theoretical distribution which is called normal distribution, which is called parent distribution. So this normal distribution is called the theoretical distribution. Why this theoretical? The form we can derive so many distributions. The which are the derived distribution, those are called the sampling distribution. So this the normal distribution is the theoretical distribution. But T, chi-square, A, these are called sampling distribution. Because these are derived from normal distribution. And again, normal distribution, these are also the derived from binomial distribution. Binomial distribution. So if you ask me, which one is the parent distribution in statistics? The name of the parent distribution in statistics is hypergeometric distribution. Hypergeometric distribution. From where we can derive binomial? From binomial we can derive normal, and then one by one. So naturally our continuous distribution starts from discrete distribution. Because hypergeometric basically is discrete distribution. I am not going into that. So many distributions, something exponential, so many. But we have to think about only normal for our research purpose, T, chi-square, and I am telling for you all. So when you solve any kind of regression analysis, something, then F test will take a very important. F test. It has a name that is called global. Global test. All other local. And since F is the global test statistics, definitely it is very significant. Question is why it is significant. Very interesting. Our main objective is how to minimize error. Okay. So I am going ahead. No need of statistics, just like the concept. Say model by error. Simple. We have model, we get some model, and there are some error. And we take some ratio. If model is less than error, can you tell me it is good? This is error. If the model sum of square is greater than error sum of square, it is good. Am I wrong? So naturally, if the model greater than error, then the model by error greater than 1, and that is nothing but f. So when f is very large for any kind of regression analysis, so that is good. Simple, no need to know statistics. And if you go for statistics, there is so many things. If it is the ratio of 2 chi-square, again chi-square is derived from T and normal distribution, so many things. But this is very basic thing. F is the ratio of two models. And this, why F is important? When you go for any machine learning, F will play. Only F will play. Now, so now another thing before starting geometry, what problem we face? Say you are solving, since in this class there are so many computer science teachers, that's why I am taking this advantage. You will face some problem. there is a term in analysis that is called greedy algorithm. That is called greedy algorithm. Greedy algorithm. So what is that? Suppose you get some problem. There are 10 cases, 10 observations. It's a real problem. But 15 variables. Am I wrong or right? But the number of cases is less than number of variables. Sometimes it will occur. In maximum social science, we are solving number of cases are more than number of variables. But in some cases, I am telling you, some cases the number of cases is less than number of variables. This is the problem. So with the conventional regression method, it can be done. So there are some greedy algorithms. The name of the algorithm is called forward regression. Forward regression. Very important. Because today, due to time, forward algorithm, this is an algorithm. But question is, in our social science, number of cases more than number of variables. And say there are 10 variables. Our objective is how to reduce the variable, which are not important for predicting the dependent variable. So how we can reduce it? So that algorithm is called backward regression. Backward regression. Very interesting. Now when we apply backward regression, when the number of cases more than number of variables. And most of the cases in our case. Because our maximum research based on samples. Now, this is one problem already I have solved. I will solve when you apply regression. And all these, forward regression, backward regression based on p-value. So I'll keep the concept of p-value just a little bit back. Next. Another concept, in regression, you will face multiple regression. This is very, very important. Very, very important. So what is multiple? Suppose you have 4 independent variables. Am I wrong, right? Is it clear? 4 independent variables. Now, when there are 4 independent variables, try to follow. When there are 4 independent variables, we construct 4 regressions. When there are 5 independent variables, we construct 5 regressions. That means when there are p independent variables, p regression. Is it okay? Now how can it? So regression means obviously one dependent and more than one independent. So x1 is a function of x2, x3, x4. This is one regression equation. That is x1 dependent, x2, x3, x4 are the independent. Similarly, x2, that is x1, x3, x4. That is x3, x1, x2, x4. And lastly, x4, that is x1, x2, x3. Is it okay? These are the 4 equations. So naturally, what you can get, suppose if we solve this regression equation, we get first thing, how much x1 can be explained by x2, x3. That is R1. Yesterday I explained this. Thank you. How much we can explain x1 with the help of x2, x3. That is called R1. Why I have taken R1 square? From R1 square notation we can understand x1 is the trigger. So in the research paper you can write this notation. So this is R2 square. This is R3 square. And this is R. But the problem is when you take the help of software, you will not solve all integration. This is for concept, actually. So we take the help of one measures. Because R square is called explained part. Explained part. 1 minus R square is the unexplained part. Is it clear? And we know the R square is lies between 0 to 1. And obviously 1 minus R square lies between 0 to 1. And since 1 minus R square lies between 0 to 1, it is a fraction. So really it's difficult to deal with the fraction values. So how can we make it integer if we divide 1 by fraction? That is, if we divide 1 by unexplained part. And that is equal to 1 by 1 minus R square, and which is nothing but, which is called BIF. What is BIF? You can write variance, inflation, factor. Variance, inflation, in this way BIF start. Okay. That is why 1 by unexplained part. And actually in any book you can see that unexplained part is called tolerance. How much we can tolerate for multiplication. And maybe. No, we get the x1 BIF, x2 BIF, every BIF. I will show you the backend part. Front-end part when you solve software. I am interested, seriously speaking, in backend. Because front-end will take 5 minutes. If result. So nothing. Front-end part simple. YAMLs, SPSS, R, Python, these are basically front-end. Coming into, I am basically interested for the backend. How they are doing. Can I start? So that is, so when you get BIF, they are very interesting. So BIF basically 1 by 1 minus R square. So just a thing. So R square lies between 0 to 1. It can never be negative. So if R square equal to 0.5, 50% explained. Am I? R square is greater than 0.5, more than 50%. In our social science research, someone working in the primary data, someone working in the secondary data, also someone working in the experimental. So when we will work in the primary as well as secondary data, so definitely some criteria will change. So what is the criteria? For the primary data, I am telling you, for the primary data, you consider if you take R square equal to 0.5, then what is the BIF value? 1 by 0.5, that is equal to 2. Is it okay? Because if we take R square equal to 0.5, 1 minus 0.5, 0.5, 1 by 0.5 equal to. Okay. So we can give some conclusion that if BIF greater than equal to 2, that implies multi-collinearity occurs. Multi-collinearity occurs when BIF greater than equal to 2. Clear? Now come to the point, R square is equal to 0.8. What happened? Then R square equal to 0.8, then BIF equal to 1 by 0.2, that is equal to 5. So in some cases, if BIF greater than equal to 5, for some experimental research, multiple people. If you work in chemistry, you have to consider BIF greater than equal to 5. If you work in the mechanical engineering, computer science, you have to consider, because that is the experimental design. Huge chance of multiplication. And if R square is equal to, don't mind, I am telling one, I will not refer the name of the book, because this is a famous book. Everyone studied, but in that book some lines are wrong. Don't mind, I will not refer the book, it is a famous book. In that book it is written that if R square equal to 0.9, so there it is coming, that is equal to 10. And in that book it is given, that is the social science research book, if the BIF is greater than equal to 10, multiple in some literature suppose that, I don't know. Is it possible? In the social science research, we all times we have, we can say there is a high multiple. So definitely we can give some range. We can give some range of multiplicity that is 2, 5, 10, and this is the less than 2, no multiplicity. This is the average multiplicity. This is the high multiplicity. And this is the median. That decision you get. Is it okay now? So now when you write in the research paper, you write this. So this is very important. Now question is, suppose today you start one problem now. Initially you start with the 9 independent variables and 1 independent. And since there is 1 dependent and 9 independent from the domain, so we consider it says since you get dependent and independent, so definitely we take the chance of solving the equation. We take the chance. Is it okay? And I will show you that regression failed. Regression failed. So there is a concept in data science. The concept is called the feature selection. And for the feature selection, there are so many techniques. The number one technique is the correlation. How we can apply correlation to get the features, important features. So that is one, the technique. Second technique is the regression of feature. Third technique is very interesting. There is the embedded system. That system is called PCA. Yeah, how you apply PCA? PCA with picture. And the last one is very important. You know, very, very important is the today's study going on. And that is called the descriptive analysis. Rich regression, lasso regression, and descriptive. These are the latest studies. And if you write any paper on regression analysis, then you can on any PCA factor. And if we apply lastly the reach, lasso, and elasticity for any kind of the regression or classification problem, and very because this is the optimization. Reach, lasso, and so now I will start one. Can I Bandopadhyay? After lunch.
Lunch what are they?
Before lunch, I have started with some Jamovi portion. I will show you some correlation part. I will solve Jamovi. And definitely for Jamovi, you need some concept how we start Jamovi. Okay. And then I will probably second half I will take. So before that, I'm showing you one result. Just wait. Say, very interesting. So this is the current start point. So this is the normal distribution. This is the normal distribution. And in normal distribution, this is minus infinity to plus infinity. And this is your. So it's my request to all of you, in most of the research based on normal distribution. So try to remember the probability density function for. So what is the probability density function for normal distribution? That is 1 by root 2 pi sigma e to the power minus half x minus mu by sigma whole square. This is called probability density function of normal distribution. And where x lies between minus infinity to plus infinity. So I am telling you in the research paper, don't give equal. Don't give equal. Question is why? Because in our mathematics, there is a concept of extended real measure theory. So definitely normal distribution, when you integrate this function, we take minus infinity. But when you write the rotation, you give this minus infinity. So that's why this is no end. Not touch the extreme left and extreme right. This is a very interesting symbolic interpretation. So this is try to remember. Question is why? Because when you get some test of statistics value, say T is a test of statistics, chi-square is a test of statistics, F is a test of statistics, and Z is a test of statistics. These are tests. And definitely, when you calculate any test of statistics, we calculate under H0. You can ask me the question, why under H0? Because under H0, the parameter is completely specific. Under H0, you know what is the value of mu equal to 5. You know rho equal to 0. You know beta equal to 0. So under H0 parameter, population parameter is completely specified. So when you use some test of statistics, so then you calculate the test of statistics under H0. And when it is under H0, you get the value of T. I am not going in detail, that is given in any textbook. So when you get this value of T, that is basically observed value. And that is your, suppose I am getting Z value, then you can understand Z value. So this is the observed value. And that is your distribution, theoretical distribution. So what will do that? Very interesting. Suppose you get the value of Z is say 2.5. Suppose you get some on the basis of a sample of values. Then what will do then? We know the Z continuous distribution. And continuous distribution means we take the help of integration. I will not tell the integration concept, just giving the concept of P value. We will take the concept of take the help of integration. So how we take? Since your calculated value is 2.53 and we integrate this probability density function Fz, while Z, because we convert into standard normal, So what is the advantage of standard normal distribution? Mean zero and standard ratio. This is the advantage of standard normal. We convert into mean zero and standard ratio. So we integrate this standard normal variant. Integration means there is some decay. There is some decay. And obviously we know the normal distribution starts from the lower limit minus infinity. Is it okay? And what is my calculated value? 2.5. So very interesting. If we integrate from minus infinity to plus infinity, we get the total probability 1. Because we are integrating total area. But when you integrate from minus infinity to 2.5, you will get some ratio, not the full ratio. And definitely, if we get this value, you know, I'm telling you, say you are getting this value, say 0.97. Suppose. Not equal to 1, it is less than 1. Because if you integrate minus infinity to plus infinity, you get 1. But when you integrate minus infinity to some point, definitely it is less than 1. That is the concept of 6 sigma level. We are using the manufacturing system. That is the concept of 6 sigma level. We are using in the mass production system. Same thing. We are getting the result. So 0.97. And now this 0.97, that is equal to 1 minus alpha. That is equal to 1 minus 0.3. Is it okay? Now you try to understand. This covers how much? How much? 97%. So this 97% means remaining part is 3%. Is it okay? Remaining part is 3%. So this 3% is less than 3% is less than 5%. This 3% is less than 5%. So when it is less than 5%, we reject H0. We reject H0 because we are considering 5% level of significance. So that's why there is every standard software. If your p-value greater than 0.05, H0 is not rejected. We accept it. And I am telling you in the research paper, most probably before 2 months, one very good research paper has written. But don't say we accept H0. Accept H0 is very bad word. We will say do not reject H0. Do not reject it. If we say accept H0, that means we are accepting manufacturer 100%. We do not develop. Some research papers are saying this sentence, do not reject it. Okay. Is it okay? So that is, if p-value greater than 0.05, we accept, do not reject it. And definitely if p-value less than 0.05. So now the last part. Why are debating? This is the real question. Why we are debating from the conventional statistics? Conventional statistics, tabular value, taking the time to the p-value. Because for some problem, you get p-value is equal to 0.06. Am I wrong? For some problem, you get p-value 0.53. For some problem, you get p-value 0.98. So definitely your conclusion will change. So degree of acceptance, it is a very poor acceptance, average acceptance, strong acceptance. But in your conventional statistics, only we are saying the statement accept. But we convert into the degree of acceptance, some fuzzy concept. So this is very, very important term. That's why we are using the concept of p-value. And we know the p-value lies between 0 and 0. And recently, when you apply softwares, you will get a very interesting method using Jamovi, SPSS, then suppose if you get the value of P is equal to 0.000, then you tell me what is it correct? Maximum. You are telling, okay, H naught is highly rejected, but you are getting the P value is 0.2. But there is a concept P is the probability. And there is a concept P can never be 0. Because if P is equal to 0, that is an impossible event, but we are accepting this. Yes, this is given, Jamovi is given, R given, Python given. What is the problem? Problem is that when a space is given this value, so they are taking the 3 decimal places. So then you have to, in your research paper, you have to make it customized. Instead of 3 point, you have to write, maybe some cases, it is 001. Because this is the demerit of, some software. You have to change it, because what is the probability value? So probability value can never be 0. Probability value can never be 1. That's why I have written P lies between 0 to 1. It's a probability. Because if it is 1, it is certainty. Don't mind, but this is very, very important issue for publishing the clinical journal. So just demo it. So for the 10 minutes, Sam will take the class on Jamovi. Sam, just you start Jamovi, how to start Jamovi.
I think you are already installed in the system and PC of Jamovi. It's a very easy to install. It's a open source software, not like Spaces or any other free software. So you can just go to the Google and download. Am I audible?
No. So I hope you install Jamovi. Yes.
Anybody who has not installed Jamovi, anyone there? With Jamovi not installed on their machine? শান্তি দেখে নে যদি কেউ থাকে যে করেনি তাহলে একবার বলে দে ছোট।
So repeating the process means how to install. It is very easy to install. First you go to Google or any browser and just write Jamovi. Download. And this is the site that is www.jamovi.org. From that site, if you click on that site, you have two options, that is the solid version and current version. So in case of current version, that is the running version. All the packages, new packages and the old packages changing the functions in the current version. So I prefer only use to solid version, because if you are using the current version, say day after tomorrow, it's changing, some functions are changing, some codes are changing, so it will be get some problem while doing your analysis. So just click on the solid version, that is the current solid version is 2.2.5, and just click on that, it will be automatically downloaded. And after downloaded, the easy process to install, the double click on that particular software application, it will automatically install. So if anyone not having installed the Jamovi, so please install it first. So this is Jamovi. This is while opening the Jamovi, you will find two dialog boxes. That is two components. That is one is data component, and another is there is written nothing. Right now it is nothing written there, because whenever we are doing our analysis, the analysis shows in the right hand side, right hand side part. So first is, as sir already yesterday told about SPSS, there are 5 components in SPSS. So Geometry has also some components. So obviously there should be some data components, some variable components. So as you can see in the left hand side, that is it is written there that in the column, that's A in the nominal, and there is some picture that is showing that is nominal. The type of data will be nominal, same as B, same as C. So just click, if you click on that, I think all of you doing together with me, right? Yes. Okay, so just click on that A, particular A, you can see that the data variable where a text box is there and it is written there A. Now you can change that particular A with your name, that's any type of name, any type of variable name. So everybody know. Already open, Geometry file open software. So there is 2 components. One is the data component, one is the analysis part component. Right? So now in the data component, you will initially by default there is 3 levels are there, that is A, B, C, 3 columns. And if you click on A, then you can see a window that having a data variable, and under that data variable, that is the input box, that is A, written here A by default. Now you can change it by your own variable name. Say I am checking that name. Right? So obviously name should not be in this numeric form. It should be in a character form or string form. So after that, there is also description is there. In SPSS yesterday we have column that is named as label. So description. Here it is the label is here written as a description. Now name of what? Say I am writing here name of Roy student. So it is a description. The name of what? Name is my variable name, and if in the description box I am just writing that name of a BC Roy student. Next is, as I told before, that name should not be in numeric form, it should be in character form or string form. So it is, measure type is nominal, and there under that measure type there is a data type that is written here integer. So just click on first nominal. Yes, sorry. Just click on the integer that is written there text. So my first name is created. Okay. So there is an arrow option. If you click on that, it will hide. So the first is my name, which is a string, which will contain a text. Let me write my name of child. If you want to give any numeric value, it will also take, but in case of analysis, it will not giving the correct analysis, as because already in the name portion I already given the data type should be text. So if by chance if you are giving a numeric value in particular column, then it will give you an error, as because it is the data variable is a text. about the unique identifier. Means in computer science there is a primary key, there is a unique identifier. The ID is a unique identifier to identify a particular person. Yes, yes, yes. Unique identifier. Now in the second column, that is B, I am taking that is what should I name?
আচ্ছা নেমটা
Roll
কি
number.
টাইপ
Say
দিতে
roll.
হচ্ছে ডেটা টাইপ ক্যারেক্টার টেক্সট
Roll number. They are
Measure
taking the
type?
roll number.
নমিনাল
So
সেকেন্ডটা কি
second roll number.
রোল নাম্বার ঠিক
হ্যাঁ।
আছে
Roll number. And in the measure type, I am giving these as because roll number is in a scale version, so I am giving continuous. And data type is integer. But in case of integer means if you take the decimal instead of integer, then it will take the fraction value. But roll number, as because we don't have a fraction roll number, so we take a integer.
ছায়া এই মিস
Sometimes 2 or 3 left in between. What do you do that? Say there are 20 students.
Yes.
Roll number 16 and roll
আচ্ছা
number
মিসিং
18.
No, no,
There's no
there is a scale, continuous scale. Here the measure type is, the measure types are nominal scale.
So is it
Yes.
better to put ID?
You can put ID also. You can put ID also.
You can put ID also.
ছায়া
Yes.
এই মিসিং ভ্যালুটা কি ডিফল্ট ভ্যালুর জন্য
হ্যাঁ?
মিসিং ভ্যালুটা কি ডিফল্ট ভ্যালুর জন্য
মিসিং ভ্যালু তোমার যদি থাকে, বেশ কোনোভাবে কোনো জায়গায় মিসিং ভ্যালু আছে, তো ওটা তুমি মিসিং ভ্যালুটা এখানে দিতে পারো।
আচ্ছা
ঠিক আছে, মিসিং ভ্যালুটা এখানে অ্যাডজাস্ট করা ছিল। তোমার ধরো তোমার ওইখানেও তোমার একটা ভেরিয়েবল আছে, সেটাতে 100টা তোমার অবজারভেশন, তার মধ্যে কিছু মিসিং ভ্যালু আছে। ঠিক আছে, তুমি এখানে ডিনোট করতে পারবে যে এত নম্বর অবজারভেশন ইজ মিসিং, দ্যাট মিসিং ভ্যালু।
আজকে এটাই দেওয়া যাবে, আমি যেটা বললাম রোল নাম্বার 3 আর 17 নেই,
হ্যাঁ।
মিসিং ভ্যালুতে আমি রোল নাম্বার
ওই দুটো দিয়ে যাবে আমাকে ওই প্রশ্নটা পরেই আমি জিজ্ঞেস করলাম যেটা
দেওয়া যাবে।
Now, next is C. There I'm taking that is say marks. Yes. Now, in case of marks, I'm taking the measure scale continuous, and I'm taking decimal. Why decimal? Means say 48 or 68.5. Someone is getting a marks of 68.5. Someone is having a marks of say 70.2. So I'm just taking as because I need to justify the decimal. How do we put the decimal value? That's why I'm taking that as a decimal. Otherwise, marks in Indian case it's always in the integer form.
It is average marks it may come.
Yeah, average marks in Indian. So this is how I can means form my data sheet that is having a name, roll number and marks.
মার্কসটা না কন্টিনিউয়াস আসছে,
And because marks,
আমি ডেসিমালে দিলেই কন্টিনিউয়াস আসছে,
হ্যাঁ।
ইন্টিজারে দিলে কিন্তু নমিনাল দিচ্ছে।
the automatic you have to change means আপনি যদি
আমি যদি ইন্টিজার
হ্যাঁ,
দিই তাহলে
চেঞ্জ করা
কিন্তু
যাবে।
নমিনালে আসছে, নমিনালও আসছে, কন্টিনিউয়াসও
হ্যাঁ।
আসছে, কিন্তু দিলে ডেসিমাল দিলে অটোমেটিক ওটা কন্টিনিউয়াস হয়ে যাচ্ছে।
হ্যাঁ ডেসিমেলে তো নেবেন, নমিনাল স্কেল তো নেবেন, ডেসিমেল পয়েন্টের পর ফ্র্যাকশনের পর ফ্র্যাকশন ভ্যালু কখনো নমিনাল করে দিলে নিতে পারবেন না।
নাও হতে পারে না মা,
কিন্তু মার্কস তো অবভিয়াসলি কন্টিনিউয়াস আছে।
আপনি 50 30 পেয়েছিলেন, 50 শূন্য পেতে পারে,
অর্ডিনাল হতে পারে,
25 অর্ডিনাল হতে পারে,
অর্ডিনাল হতে পারে, বাট অর্ডিনাল হতে পারে, অর্ডিনাল হতে পারে তখনই যখন মার্কস যদি ধরুন আপনার কোনো গ্রেডিং আপনি করছেন যে পড়া সাবজেক্ট মার্কস একজন স্টুডেন্টের জন্য আপনি
ভ্যালু চেঞ্জ হয়ে যাচ্ছে, ডেসিমাল দিলে শুধু কন্টিনিউয়াস আসছে।
আমাকে হোয়াটসঅ্যাপ করেছে আমার পেন ড্রাইভ
অর্ডিনাল দিলে টেক্সট ওটা এখানে দেখছি যখন অ্যাট দ্য টাইম অফ অ্যানালাইসিস যখন আপনি অ্যানালাইসিস করবেন তখন ওটা নেবেন, ওটা এরর দিবে।
continuous and change.
Ordinal data type takes. Okay. Ordinal data as because we are doing the HPSS where we are keeping that ordinal whenever we are ordinal and we can put the value as because it's ordinal put in the value level we are putting that one is for agree, two is for disagree, like that, right? So here also yes here also ordinal for ordinal obviously there is some order. It will make some order. That's why it's given a text and in text say I'm putting one, right? And now one can be written as say associate, right? Now I'm putting two. Now that is say professor. So now we can see that as because it is giving ordinal, so it maintains an order and order cannot be in the fraction form. That's why it's given text. And in our SPSS in earlier whenever we are using the SPSS, so we are giving in the value level whenever we are using the method type of ordinal in the value level we are putting some one say one is equal to say associate professor, two is equal to say professor, like that just in an order form. That's why in text also here you can see if that is taken, one is taken as associate and two is taken as professor. That's why it's given in data type is text. It is showing in here as text, but it will text. Yes.
Decimal नहीं problem, वो शुरू ही continuous है. और इधर text का नीचे 1 2 लिखा है.
Continuous decimal. Continuous should be decimal. It should not be. Means আমি বলবো না আপনি continuous আপনি কি মানে decimal আপনি continuous কি মানে continuous এ কি চাইছেন? হ্যাঁ continuous হ্যাঁ.
Marks का continuous না
হ্যাঁ. না আমি মার্কস যদি একটা সাবজেক্টে নিয়ে পেলাম ঠিক আছে আমি আই এম নট টেকিং অ্যাজ আ স্টুডেন্ট আই এম টেকিং আ সাবজেক্ট 100 কে 100 আর মার্কস এটা কন্টিনিউয়াস লাইক দ্যাট
I'll show one thing where you can import the data from SPSS to Java, which is required for our.
Okay, for data importing means there is
This is very important part. How to import the data from SPSS to Java. How to import the data from Excel to Java. That is a very
তোমরা
important.
উল্টোটা করা যায় জামুবি থেকে এক্সেল বা
Java
এসপিএস
থেকে Excel এ output নিয়ে যায়। তাহলে Excel তো অত নিয়ে কি করবে না?
হ্যাঁ সেটা আমি জাস্ট জানার জন্য
Excel এ নিয়ে কি করে? Excel তো একটা মানে ব্যাকএন্ড এ ভিজুয়াল বেসিক।
বড় আউটপুটটা নিয়ে গিয়ে কাজে লাগে
Excel এর একটা লিমিটেশন আছে ব্যাকএন্ডটা ভিজুয়াল বেসিক।
হ্যাঁ।
কিন্তু অত পাওয়ারফুল
না
নয়। কিছুটা ম্যাক্রো ইউজ করে অ্যারাউন্ড করে এখন কাজ করছে।
হ্যাঁ
ঠিক আছে? এখন যে অপটিমাইজেশন ইউজ করছে কিন্তু আলটিমেটলি কিন্তু তার জন্য অন্য টুল আছে। তাহলে আরো সহজে করা যায়।
জামুবিটাকে আরে নিতে পারবে
আরে যাবে মানে হায়ার এন্ডে যাবে মানে ওর ব্যাকএন্ড এন্ডে যাবে।
now to import any type of file means Excel file SPSS
আপনি
file
কিছু না এক্সেল এই যে ইনপুটটা এলো ইউ ক্যান ইজিলি কপি এন্ড পুট ইনটু এক্সেল মানে কোনো ব্যাপারই না।
there is a 3 bar as you can see in the left corner right.
Sir, you just I have a package try to understand. I have a file in SPSS. I have a file in SPSS. I want to import the file from SPSS to Java because I want to work in Java. Is it clear? So import file we can that is the SPSS extension is not SAB, it's SAB. And we can import the file Excel CSV file. Okay, so you show how we can import SPSS file. Better you import the BSc Sensex because now after lunch I will start the working on BSc Sensex. You import the file BSc Sensex from SPSS to Java.
গৌতম দা যে ফাইলগুলো দিয়েছেন তার মধ্যে আছে তো
Now BSc Sensex টা ডাইরেক্টলি দেখলাম।
ও ওটা কি
এটা আমি দিয়ে দিয়েছিলাম।
আমাকে দিয়েছেন তাহলে দেখি আমি দেখি করি
BSc census.
হ্যাঁ তাহলে
How we, this is very important. How we import the BSc census from SPSS to Jammu. Sir, it is.
So just
BSc census or BSc.
just click on the right left corner and there is a 3 bar here, and after clicking you will have a dialog box like this. So here you can find that new open import. So just click on import, as because we are importing the file. So after clicking,
I am telling you, make slow because this is very important. I am telling you this is very important. Again repeat. So one by one, step 1, go to that. What is the step 2?
bsc.sav ফাইলটার নাম
BSc census. Because under factor.
আচ্ছা
The madam requested me factor lucid way.
হ্যাঁ
I will show you factor.
দিচ্ছি আমি খুঁজে দিচ্ছি
Start call.
so here you can find a dialog box having 6 options, that is new, open and import. Just click on import and
Clear? Huh? Next.
now the second step, that is here it is given that text box, and just above that text box that is the option browse. So you better know where in your computer where the file, exact file of SAV or .xl file is there. Just click on browse, and after clicking on browse again a window will open where you can find that there is a path of particular file where is the file is located. So here in search computer the file is located in desktop and under BCRO folder, and file name is BSc census under factor.
এক্ষুনি দিচ্ছি এক্ষুনি চলে যাবে
That is the file name. I think just click on that. If you double click on that particular file, it will be automatically open.
নেম না করা থাকলে ফার্স্ট
Sir,
Please wait until everybody has received the file.
okay.
জাস্ট 1 মিনিট
You can import also Excel dot CSV file. But XLS now, CSV.
আচ্ছা অনলি সিএসভি
Only CSV, not XLS.
নট এক্সেল
Not XLS. The CSV is have.
এই বিএসসি সেন্সেক্স ফ্যাক্টর যেটা আছে এটা তো
হ্যাঁ
ওটাই পাঠিয়েছি সবাইকে
Mainly Jamobi basically used for social science research. There are so many options. So shall you go to the Jamobi?
সবাই পেয়েছে কেউ কেউ পেয়ে থাকলে তাহলে বাকিরাও পেয়ে যাবে এটা কি করে মিস করলাম আমি অপূর্ব আচ্ছা তো। কেউ পাইনি এমন আছে
So just you go to the how to import the file. Just you import the file from SPSS to Jammu.
I'm showing the step again. Click on browse.
You can go to browse, and from browse you go to your destination of your computer. So my destination is under desktop. Under BCDOI file is okay. You select this.
এই দুটো কলম আছে তো গৌতম দা
To do a
So initiate. because that's the default. By default, Java will give the 3 column. Whenever you are just opening your Java will,
ও আচ্ছা আচ্ছা
the 3 column will show. You can remove or it, or in the analysis you don't take that file. Means they don't take that column. That is the main way. Yes, you can delete.
Better, I am telling you, better you delete those columns.
First 3 columns.
Better you delete the first 3 columns.
মানে যে তিনটে পড়েছি নেম রোল নাম্বার মার্কস এইগুলো ডিলিট করবো তো
হ্যাঁ ডিলিট করে দিন নেম হ্যাঁ মানে প্রথম কি
স্যার কিভাবে ডিলিট করবো
Excel is showing as because
এটা কারেন্ট ভার্সনে দিচ্ছে
maybe they sound
মেবি সলিড ভার্সনে দিচ্ছে আগেকার ভার্সনে দিচ্ছে না এটা দিচ্ছে কারেন্ট আমরা যখন
actually the problem of Excel as because in Excel we have a 3 sheet. Initially we get the 3 sheet. Now the problem is that whenever we are importing an Excel file, to which sheet will be open? That is the main problem. That's why we are
Somebody tell me, get this file, all. Huh?
got it.
So Shayan, show it for the descriptive statistics exploration. All the 3 আছে আরে select. Is it okay?
এক্সপ্লোরেশন
Exploration.
Just click on exploration.
Just click on exploration.
And under exploration there is a option of descriptive.
Here. Select descriptive. Just to check. We select sensex. Is it clear? Hello? Clear?
Click on the toggle switch.
Just to check. When you select sensex, all values appear in the right hand side. So that is the input, this is the output. Very simple.
ও থেকে আসছে না
So how many observation? 39, no one missing. Mean is given, median is given, standard deviation is given, and minimum observation is given, maximum observation is given. Is it okay? Sharon, again go to the next final initial position.
হয়েছে
Already? Browse it. Can I find it asking?
ওটা ইয়েতে ডাউনলোডে থাকবে শশী ডাউনলোডে থাকবে
Sharon, exploration. Is it okay? Exploration, go to descriptive. Clear?
ভালো না সুভাষী
Now select sensex.
ভালো সবচেয়ে বড় কথা কি
Then gold.
পয়সা
Gold.
এটার বেশি কোনো নাই, লাল হয়ে গেছে।
Here. Just when you select this, automatically value does come.
হ্যাঁ ও বলেছে ওই এবার হয়ে গেছে আর কত লাগবে লাইন লাইন ছিল আর হবে টাইম হয়ে গেছে ওভার হয়ে গেছে
এটা অবশ্যই
Is it okay? Huh? Problems coming.
ফোন করছে কিন্তু লাইন বের করবেন হ্যাঁ আর অল্প আছে ঠিক আছে ওকে ফোন করেছিলাম আমি বললাম দাঁড়ানো হয়ে গেছে তো হ্যাঁ ও চার্জ দেবে দিয়ে চার্জ এইটা যে চার্জারটা ইয়ে হয়নি যে আর একটু বড় করে দেখুন এই চার্জার রয়েছে চার্জার ছোটো না
Hello. So these are, I do understand, these are variables. And it is given split by. Now when you apply split by, when there is some categorical variable. So I like to split the continuous variable form with some categorical variable. Say, Simon, you go to the exploration part, this part. Go to this input, import the one. Not explosion. You open. Open this PC. What the file here? Browser here, browser GB1. You go to exploration, then this is okay. Right. So this subject 1, subject 2, subject 3, these are the continuous. These are marks.
GB1.09.
GB1. And this is the gender, the categorical variable. Now you want to split with respect to the gender. So go to exploration descriptive. Select subject 1 or select one variable. Subject 2, subject 3. Now split by gender. Is it okay? This is the real effect. You can split any kind of continuous variable with respect to categorical.
Wow, beautiful.
Is it okay? Now, Sharon, you go to exploration. Sharon, you go to plots. So these are so many plots. So now you go for box plot.
Sir, data than a census.
Same data. I mean GB data. Plots.
Exploration again.
Descriptives.
দেখুন, all plots are
Plot.
box plots. First of all, subject 1. Subject 1, since I have taken gender, so for the male female. Subject 2, male female. Subject 3, male. Is it okay? Now you go to the violin plot. Is it okay?
বক্স
সিলেক্ট করার পর কি প্রেস করতে হবে এটা পাওয়ার জন্য?
প্লটস নিচের দিকে দেখবে।
Then you go to
প্লটের বক্স প্লট
Plots আছে দেখবে,
বক্সটা সিলেক্ট করেছি।
আর নিচে আবার হিস্টোগ্রাম, প্লটস।
সব সিলেক্ট করবো?
না, প্রথমে
আমি শুধু বক্সটা সিলেক্ট করেছি।
Is it okay? You get all types of diagram, but you have to
আসছে তো,
analyze
আমার
from
আসছে
your
না তো।
সাইডে আসছে ডেসক্রিপটিভস এন্ড আন্ডার।
Sharon, to our প্রথমে চলে যাও। Start from beginning. Okay?
গৌতমদা আমার এইদিকে তো আসছে না।
আসবে এখনই। Start from beginning. Exploration. Select. Print by gender. Clear. এবার তুমি প্লটে চলে যাও, প্লট খোলাই আছে। হিস্টোগ্রাম, বক্স প্লট, তার আগে একবার then box plot. Clear? Huh? Before lunch, eat some लोग?
স্যার আমারটা সিলেক্ট করার পর আমি সিলেক্ট করব। কোনটা সিলেক্ট করব? এইটা?
এটা সিলেক্ট করে ডান দিকে নিয়ে আসুন।
এইটা? হ্যাঁ, তাই গেল।
মানে এবার ডেসক্রিপটিভ
বলো।
सब्जेक्ट 1 थे सब्जेक्ट 2 बाय
থ্যাংক ইউ। আমি ওইটাই করি, আমি একবার করে আবার বেরিয়ে গিয়ে আবার করি।
ভেরিয়েবলটাকে তো নিয়ে যেতে হবে।
ঠিক আছে, থ্যাংক ইউ। ভায়োলিন প্লটটা তো দারুণ।
কি দারুণ দেখতে না?
হেভি দেখতে ভায়োলিন প্লটটা।
চলে এসছে ভাই।
ওকে এসছে
হ্যাঁ ও তো রেডি, বলে আসবে, বলে দেবে।
Let us take a lunch break and kindly move to the FMS department in the main building to have your lunch. Thank you.